Good day, everyone, and welcome to the Engineer Construction Lecture Hub. Today, I want to discuss a very sensitive topic, and the topic is how to interpret how to interpret how to interpret structural drawings. How to interpret structural drawings. That's the topic for today. Now, as you know, structural drawings shows details of the reinforcements in our various structural components. You know, the essence of our design is for us to design and provide reinforcements that are suitable, for that particular structural component. Okay, so having gotten those provisions or having obtained those informations of reinforcement, it is important for us to now detail those informations, okay, into drawings. All right, so these drawings are what we present as output. So it is important for us to be able to look at those drawings and identify or interpret what that drawing is all about. Okay, so that is what we'll look at today. Okay, so but before we start with that, I want us to look at notations. Okay, notations. Now, for example, you have informations like maybe 20, you have something like this, 20 y12, okay, O1 at 150. Probably you might see something like this, okay. Then in some cases you might have this, okay. You might have it in this form too, okay. It could be in this form. It could also be, in this form, okay. Then as we go on, we also get to see other notations too. So when you have something like this, all right, it shows an information that is passed across. So it is for you now to understand what this information is all about. Because when you now know what this information is all about, that is when you can actually translate it, on ground. So what this means now is, it means that this 20 you have here is the number of bars. Okay, the 20 now is the number of bars. All right, the total length of bars that is required. Okay, then this y now, the y here, let's say 20 is number of bars. The y here stands for high heel steel. Okay, now high heel steel are those steel that have tensile strength of about 410 Newton per millimeter square, 460 Newton per millimeter square, and so on. So when you have such grades of steel, it means that it's a high heel steel, and most times they have a deformed surface area, a surface texture. Okay, so such steel are what we refer to as high heel steel. Then in some cases where you see instead of y, you have it as t. Okay, you have it as t. It still means high heel steel. So for example, you might not see it as y. Probably you see it as t. Okay, it still means high heel steel. Okay, then in some cases you might have it as R. Okay, you might have it as R. That is, you might have it as R this way. It means R here now means mile steel. Okay, these are steel whose strength or tensile strength is about 250 Newton per millimeter square. Okay, such tensile strength of steel are what we refer to as mile steel. Okay, so as the case may be,